a graphing calculator, but today we're going to do them on this. We're graphing them by hand, okay? So let's look at these steps, okay? First, we need to find the axis of symmetry. And how do we do that? Remember, x equals negative b divided by 2a, right? So we know that. And then we're going to find the vertex. How do we do that? We plug this x value, y equals whatever, 2x squared minus 3b, or 3x, I'm just making this up, plus 4. We would plug the x in for these, and then whatever that gives us is going to give us y equals something. We graph that point. We have the x value, y value. We graph that, and so those are the first two things we're going to do. Find the axis of symmetry, find the vertex. We know how to do both of those from yesterday. Okay. Our third step, put the vertex in the middle of a row of tables. Okay, so we're going to have a table like this one. Okay, and we're going to put the vertex right in the middle. And then we're going to fill in the table of values using your calculator. So that's not using the graphing function, but using just like use your calculator to solve it so you don't have to do it by hand, right? And then we're going to plot the points on the graph and connect them. All right? So let's just do, I'm going to do maybe 2 examples with you guys and then let you work the rest on your own, okay? So let's see. Graph each. So let's identify, this is our equation, x squared. So let's identify the axis of symmetry, okay? So I'm going to work it right here. X equals, what is negative b? 0. B is 0 over 2 times 1. Well, if b is 0, then the axis of symmetry is just x equals 0. So we know that. That was really easy. And we could graph that, right? I'm going to do it in blue so we can see it. It's just straight going down that line. Okay. Then, what is our vertex? For our vertex, we would plug in 0. So we plug in y. Y equals 0 squared. So y equals 0. And we're left with 0, 0 for our vertex, okay? And I'm just going to go ahead and graph that so we have it. Let's graph this in green. Okay, that's our vertex. And then we plug that in, remember, to the middle value on our chart. So 0, 0. Now we can use our calculators to plug in some more values. So like if we were to plug in negative 2 to this, it would be negative 2 squared is 4, okay? And then if we plug in a negative 1 squared is 1. And we can keep going. 1 plugs in to be 1, and then 2 squared is 4. So here are our points. Let's graph them. Negative 1, negative 1, 1 would be right there. Negative 2, 1, 2, 3, 4 would be there. And then we've got 1, 1, and 2, 4. Okay, and now what do? We connect them in as smooth as we can, a parabola. So this is not very smooth, but, and there it is. It's graphed, right? And then it's asking us now for the domain and range. And I know it's been a while since we've talked about that, but the domain is just the x values that it can be, and the range are the y values. So let's think about the domain here. It's going to extend. This is going to go on forever, and this is going to go on forever. So x could actually be all real numbers, or an element of the real number system, which I remember y'all hated, but let's remember this notation again, okay? And then what about our y values? Can our y values, they start right at 0, and then they only go up. Is it ever going to be anything less than 0? No, it's not. So y is greater than or equal to 0. Okay, so that's what we're looking for here. We graph it by hand, then identify the domain and range. And that's what we're going to do for all these examples in your notes today. So let's look at, let's actually skip, I'm going to skip number 2, I'll let y'all do on your own, and we'll look at number 3, okay? So for number 3, we've got, let's start by finding our axis of symmetry. So x equals negative 8, and it's already negative, so then that's going to be positive 8 over 2 times negative 1, okay? So that turns into 8 divided by negative 2 would be negative 4 is our axis of symmetry, x equals -4. I'm going to go ahead and graph that real quick. 1, 2, -1, 2, 3, 4. So that's that line right there, best I can. Then we would plug in for our vertex. So we're going to plug in, it's going to be y equals -4 squared. And it's important that we think about our signs, okay? So -8 times -4 minus 17, okay? And I'm just going to tell you what that is for right now, okay? That's going to end up being -1. You could plug that in and figure it out on your own, but so it's going to end up being -4, -1 is our vertex. So let's graph that point. -4, we know it's this line, -1, so that's right there. And then now let's go ahead and plug that in right here, -4, -1, and then we're going to plot, or we're going to fill in the rest of this chart, and then we'll graph it, okay? So you could use your calculator for this. If we plug in -6, you're going to get -5. If you plug in -5, you're going to get -2. And if you're not very comfortable with this, you might pause the video right now, and as I pick these x values, just check for the y value before I actually fill it in. And then -2 is going to be -5. And so see, we started in the middle of our vertex, and then we went a couple points or below it, and that got us the left side a couple points above it. So that gets us a pretty good idea of what the graph will look like. So -6 is here, -5. 1, 2, 4. I think that's right about here. And then -5, -2 is right there. -3, -2. And then -5 is right there. And then we're just going to connect these as smooth as we can and graph them. And that's going to be our parabola, okay? And that's a pretty good graph of it, okay? And now let's think about the x values, okay? Go all the way that way, all the way that way. So x values element of the real number system. That's our domain. X values range is our y values. And let's think about our y values here. They start at -1 and then go down, right? They're never going to be above -1. There aren't any y values over here. So our range is y is less than, right, -1. Less than -1. So this is 2 examples of how to do this. Work through the rest of them on your own. Work through your notes. You can help each other if you need to. But you can check them if you remember how to graph in your calculator. You can check them with your calculator. Don't use your calculator to do it. You need to be able to do it by hand. There will be calculator active and inactive portions of your test to make sure you can do this by hand. So don't cheat yourself by using your calculator. But help each other out and get this done. So guys, I just want to take a minute to remember what we talked about yesterday. And the first thing we talked about was what a quadratic is, what the standard form of a quadratic looks like, and that was y equals ax squared plus bx plus c. And remember, it's important that we remember that a is associated with the x squared term, b with the x term, c is our constant, okay? So this is standard form. The standard form, it's important we know what that looks like, okay? Standard form. And then what else we talked about? We talked about what a parabola looks, or what a quadratic equation looks like, which is a parabola, right? So it could be something that opens up if our x squared term is positive, or it could be something that opens down, right? Like that, if our x squared term is negative. So if it's positive, it opens up. If it's negative, it opens down. We talked about all that yesterday. And then what was one of the other things we talked about yesterday? We talked about finding the axis of symmetry, right? So if we have a parabola, pretend it's exactly the same on each side of the axis of symmetry, okay? And how do we find that axis? It's x equals -b divided by 2a. And that gives us our axis of symmetry. And then from there, we can find, I'm going to just call that a of s, axis of symmetry. And from there, we can find our vertex, right? So our vertex is the point on the axis of symmetry, the point where the parabola to turn. So it would be either the maximum or the minimum. And we can find that by plugging in, right? So we would take this x value and plug it into our quadratic equation, and it would give us something like -1, 2. And that would be our vertex. And then we can use whether or not the x squared value is positive or negative to know whether or not it opens or down. So we figured out that using just our axis of symmetry, the vertex, we're going to pretend it's there, and knowing whether or not it opens up or down, so we're going to pretend this one opens down, right, that we could sketch a quadratic pretty well, right? Well, today, what we're going to talk about is graphing by hand, okay? Graphing by hand a quadratic equation. And tomorrow